Thank you, everyone. Good afternoon. I really appreciate all of you staying later in the afternoon today on the last day of the conference. Thank you. What we would like to cover today, how PepsiCo has been in this journey of building a data foundation for global data foundation for the entire enterprise. Some facts about me. My name is Bhaskar Palit. I lead the data engineering team within PepsiCo. Prior to working at Pepsi, I was at American Airlines.
Good afternoon, everyone. My name is Sudipto Das. I lead the PepsiCo Enterprise Data Foundation, platform architecture, security, governance, policy, stuff like that.
So some facts about Pepsi. We have some props here as well. So we probably encounter Pepsi products every day, right? We touch Pepsi products throughout our everyday cycle. We are a global beverage and convenient food company with large, iconic, and trusted brands. What is our journey? In this AI, I think in the last couple of days, we have been seeing many presentations done by all the leaders of Databricks that we are in this journey of generative AI. In order to take advantage of all the generative AI capabilities, what we were thinking about few years back that we have to build a global data foundation, and which is trusted data and trusted and well governed. And with that was the primary objective because we were kind of a siloed organization. I think every company go through the same exercise that there are silos of the data. As the company grows, the data sits in different organizations. But our mandate was, as we were taking this digital journey, that we have to bring all of these data together in one uniform data platform. In order to do that, we also were struggling with how do we make it easy for any data engineers to build the data in the data foundation. So we took an approach of a low-code environment. We wanted to build a low-code environment that makes the data engineers get onto the platform and environment and start building the data products. With these frameworks and the platforms, we are serving across all 6 sectors that Pepsi is like across the world. And some facts about our current environment, we run over 30 digital products on this. We have over 6 petabytes of data in our foundation framework. We also took a common data model approach. We have over 800 common data products, models inside, over 3,000 plus data assets, and over 20,000 data pipelines are running on the framework and the platform today. What is giving us this environment? It's giving us a very highly productive environment, which we are gaining our accelerations in building the data foundation. As we know in the make, move, and sell lifecycle, we were trying to bring the data from all the different life cycles of the data, whether it is suppliers data, whether it is warehouse data, or syndicated retail data. These were all within the scope of bringing all of them for all global regions into one data platform. So we started dividing the data products into several data products as well, like supplier data or consumer data or materials data. That's how we started building our data products. Underneath, these are the different various sources of the data that we had within our scope. We started our journey in the early 2022. And in order to achieve that journey, we first started building a common low-code platform as an ingestion framework. As I was mentioning earlier, that getting a good cloud engineer, good data engineer is very difficult in this market. There's a competition everywhere that the skills are growing, but it's not at a pace that what the companies who wants to go. So we created a small team, a framework team, and we started focusing on building an ingestion framework that makes it easier for bringing the data from these various sources. We added in the journey the data quality, which was very important for us to make it more easier for the data engineers to add the data quality within the framework. Auditability, that was added next into the framework. Access control, self-service portal that make it easier for people, the data engineers, to configure their data products on the platform, make it easier for even promoting the data from lower environment to the higher environment, from development to pre-prod to production, make it as a one-stop, one push button environment where you can take the data from one environment to another environment without knowing very much details about how the framework is working behind it, to make it easier for all of them. Autoloader, it was like a lot of streaming data started coming across as well. And hiding the complexity of the autoloader was also added as a feature within the framework. Dynamic clustering, scaled infrastructure. People are selecting different type of Databricks clusters. All of those, we wanted to hide those complexities as well from the data engineering team. So we devised within the framework itself, based on the data set that we have, it automatically identifies the type of clusters that it has to choose without having anyone to think about what to configure. Dependency framework, we all know when we build a very complex solution, there are dependencies of the various jobs we have to add. And that is also added into the framework inside that. Partitioning, pruning, and then the last we started adding the Unity catalog as a governance and security, because we are bringing the data from many sources, which are some are very secure data. And we wanted to make sure that the business are comfortable bringing the data into the foundation and giving the right access control to that environment. And that's why we started implementing the Unity catalog across. Sita is going to talk more in details as we go. What are the challenges that we all face today? Like we have, these are the challenges that we were seeing in the early 2022 as we started looking at how we should kind of focus on building this. So we have a complex heterogeneous data access system with no single source of truth. Like single source of truth, what we wanted to make sure there is a single source of truth for the data, and which is the data foundation. Having a centralized governance mechanisms for that. We had limited data lineage, people tracing back where the data is coming from. We had those challenges around. Limited reusability of the pipelines. People are siloed developing pipelines all across. And so there was a limited usage of reusability of the pipelines. And also like the cloud technology, which I also mentioned right, a couple of times, about finding the right engineers with the right technical skills was also one of the challenging factor. There was no unified process for provisioning different type of access requests, who is requesting what data, and governing that was also a challenge. It was not in the data lake, we didn't have it in a very structured manner. And bringing the diverse data sources or siloed connection to the sources. Like we had various sources, as you said, like everybody configuring the similar way. It was hard, like kind of as you are connecting to SAP sources, you're connecting to Salesforce, you're connecting to SharePoint data, all of these different sources of the data that we had, we wanted to make sure that the framework takes care of all of those complexities and hides the complexity from the engineering team, the data engineers. So what did we do? That's where we started building that common framework environment, which we also integrated the data model within the framework itself. So the data modelers are also provisioning the data model through the framework itself before the data engineer starts bringing the data into. So we were very much common data model focused from the beginning, from the starting itself. And we didn't want to have the data modeler go in a different direction and data engineer going in a different direction. So the life cycle started with the data modelers bringing the data, modeling it inside the framework itself before a data engineering activity can happen. So that was how the framework started the journey of integrating a modeling resources with the engineering resources together. Lineage, as we started bringing inside the framework itself, we started incorporating the data lineage capabilities, integrating with the Unity catalog lineage as well. But we had our internal lineage built within the framework itself. Enterprise-wise common lineage and data quality. The data quality, we wanted to make sure that not everybody codes the quality within their own notebook. So we integrated a framework inside that externalized all the quality configurations outside the notebook, and you can kind of change those things within the framework itself without having the code to be modified. As you are moving the code from one environment to another environment, it is just a configuration change that you have to do when you're moving the code. You don't have to touch the code to change the data quality within the, because sometimes what happens, the data scientist will say, okay, I'm okay with this type of parameter in the dev environment, but I want to change it in the production. And in order to do that, we didn't have to change any code, we were just changing the configuration. Abstracting the technology complexity, that was a central theme of it. Centralized onboarding. As we were in the previously, prior to building this environment, people are bringing the data into the cloud from all various sources and silos. There is no centralized. Auditability was very, very difficult. We don't know where is the data coming from. And when we have reviews with the audit team, we were not able to produce the right level of information that, okay, what we have the data, that is the right data from the right source. So centralizing that through this framework was very critical for us to show what data we have in our environment. I'll let there are other features as well. I think you can, primarily I will let Sudipta take the next. He will go deeper how we enable all of these capabilities governed by the security is governed by the Unity Catalog. The going to the Unity Catalog journey, we had various lessons, and I hope like what we shared today helps all of you to, as you are in the journey of Unity Catalog, because we had to support Hive Meta Store, plus when we were trying to go Unity Catalog, we had to make sure that the 20,000 pipelines that are running today shouldn't have any impact as we are migrating our foundation into the Unity Catalog. So Sudipta will take you through the journey about the various challenges and the solutions, how we solve that.
Thank you, Bhaskar. So let me continue the journey from here. Slides, I will walk you through the journey we have crossed so far, starting from 2022 to still now, and what is coming in future. So these are some of the high-level features we have implemented so far. So when we started our journey back in 2022, we always had a goal in our mind to give users a self-serve collaborative platform for multiple stakeholders so that everyone can come together, work in the same umbrella. So we built the self-service portal, which basically allows modeling, ingestion, transformation, and data serving all in under one umbrella. Along with all these users coming to the same umbrella, there was a big challenge of centrally manage the product onboarding, user management, access management, all those things. So we built another portal for centralized onboarding portal that manages product management, user access management, and various different other parts of the system management purposes. Common data quality framework, Bhaskar has already talked about. It's we used some industry standard, open source technology to build a common data quality platform framework. There are a couple of other framework I will touch base in my next slides. Lineage, Bhaskar has already told. So when we started our journey back, that time Unity Catalog was not so sophisticated. So we used our custom code to build the lineage for the entire user community that we have, because we are ingesting tons of data. So we have all the source metadata, target metadata. So we have matched those things together to build our own custom lineage solution. Common data model, Bhaskar has already told, data is coming from multiple different sources. They have multiple different naming convention. No one is speaking the same language. So we created common data model in our silver layer so that the entire data community can speak in the same language. Now, during our migration to Unity Catalog, couple of things, very interesting thing we have developed. Like we already have a very big Hive Meta Store based user consumption. So 90% of the consumption is happening through Hive Meta Store only. So when we migrated to Unity Catalog, we had to make sure that the existing Hive consumptions are unaffected. So we have to redesign our engineering pipeline such a way that we can maintain Hive and UC, both the Metastore together, with a real-time sync available between both of them. There are a couple of other things we have also custom designed, especially related to auditing, security, and governance policy. Granular level access control is another one. So when we was there in the Hive world, row level and column level access was very, very difficult and very, very challenging. So when we migrated to UC, we developed our custom solution. I will tell you in a couple of my next slides why we build a custom solution to give user granular level access control to table and the column level. These are our next couple of few roadmaps that we have. None of them needs much more introduction. Lakehouse monitoring. We will start with data quality. ABAC has many different features. We are planning to start with time-based policy so that we can give user just-in-time access for a given period of time. So that's our first goal. Quota alerting, I will come later. Lineage, you already know that we already have a custom lineage solution. We are enhancing the capability because now UC gives table API, table lineage API, column lineage API. So we are enhancing our lineage capability using Unity Catalog APIs. Data sharing is another big use case for us because we have tons of third-party vendors to whom we have to share data. Currently, we are using Azure Data Share, SFTP. There are many other different means. So we are trying to consolidate everything under Delta Share so that again we can govern the security and policy everything based on UC. Automatic tagging of PII data need no introduction, so I'm not touching that. Quota alerting is specifically kind of platform related stuff, not related to data or UC. So as Bhaskar mentioned, we are running more than 20,000 pipelines per day. So time to time we see many different quotas are getting breached. The subscription quota, resource group quota, and there are many quotas get breached. So we only got to know once the quota get breached, some pipeline has failed, then we are alerted. So we are building a framework to give us proactive alert when it crosses a certain threshold so that it alerts us before we can take corrective action. Okay, so these are on a very high level what all the frameworks that we have in the system. So we have over a period of 2 years, we have created data testing framework, logging, monitoring, DevOps, data quality, data modeling framework, as well as data serve interfaces. So, and all these frameworks are basically hidden behind the self-service portal that Bhaskar has already told. So it's because to hide the entire complexity of all these frameworks, we gave the self-service portal. On top of it is a wizard-driven low-code framework, which is scalable as well. Some of these framework are core to the foundation, like auditing, logging, monitoring. Those are core to the foundation. Rest of the frameworks are all plug and play. You can, in the portal itself, based on your need, you can plug and play rest of the frameworks like testing framework, data quality framework, data serving. So for data serving, we use GraphQL based, framework, so that people can build their own custom APIs based on the data. They can mix and merge multiple different APIs to create their own version of APIs as well. On the very left hand side, it's the medallion architecture. So if you see, the data is coming from multiple different sources, going through landing, bronze, silver, and then getting consumed by the gold layer application. So this landing, bronze, and silver are basically our enterprise foundation that we called, and all these frameworks and the self-service portal is sitting on top of this foundation. So it's when the data gets ingested, all these frameworks gets executed based on the configuration that has been made into the self-service portal. And on the next couple of slides, I will walk you through mainly with our UC migration journey. When we started around 6 months back, 6-7 months back, our UC migration. As we have already discussed, the very early of the game, we understood that we cannot get rid of Hive Meta Store overnight. We have to keep the Hive Meta Store for considerable amount of time so that both the consumption, all the existing Hive consumption is not get affected. So we have to redesign our ingestion framework such a way so that data can be ingested in both. So we have the framework works like this. Like we have a storage layer which is common between Hive and UC Metastore both. So when you say storage layer, we have multiple different data lakes. Based on our data domain, we have sales data lake, a supply chain data lake, HR data lake. We have around 16 data lakes behind the scene. Both UC and Hive Metastore are pointing to the same data lake. And there is a real-time sync happens between HMS and UC so that user can get the same version of the data from whatever route they come. On the very right side, we have all the different consumption use cases that we have. I'll cover it, the consumption patterns in different and another slides. So we have mainly 3 different kinds of consumer. We have consumer who are already UC enabled. They are coming from their UC enabled workspace to the data foundation UC enabled environment. We have consumer, which are majority of them are non-UC consumer who are coming from HMS world. So, and the third kind of consumer that we have who are not using, not even a Databricks customer. So they are using OpenSpark in some AKS cluster. So mainly these are the 3 types of consumer we have. So how they consume, I will touch base into next slides. So if you see on the very right side, we have the storage account, and both Hive and UC are connected to the same storage account. There is a real-time sync happening between both Hive and UC. On the left-hand side, there are 3 different kinds of consumers. You can see on the very bottom, we have UC enabled consumers. Like their workspaces are already UC enabled, so they can directly, it's a very straightforward. From their UC enabled workspace, they can query our the data foundation Unity catalog meta store, and they can get the data using table AKL if they have access. Now the middle one is HMS based consumer who are not yet UC enabled. They can already query the Hive Meta Store, but if they want to query, if they want to leverage the row and column level security, they can come through the SQL warehouse through JDBC. The third consumer also is the same OpenSpark consumer who do not use Databricks. They can also use the SQL warehouse to query the Unity catalog meta store. Okay, so the next 3 slides are basically the extension of this particular slide. So when all these different kind of consumer, especially the UC enabled consumer and the HMS consumer, when they query HMS or UC, there are a lot of permutation available between workspace type, cluster type, and access mode. We did some extensive testing. There could be more combinations available, but whatever testing we did, based on that, whatever we have found, there are mainly, these are the matrices available that we have tested and is working as per our testing. So this is a HMS use case. So in this case, the consumer is not UC enabled yet. So they are coming from HMS world. So if someone is coming from an HMS only workspace, if their cluster type is HMS and access mode is custom, they can query HMS Metastore, they cannot query UC Metastore. For HMS only consumer, UC and HMS plus UC, the middle to one is not applicable because it's not possible in their workspace. The SQL warehouse is the best choice for them if they want to query both the Metastore, Hive or UC. UC consumer, that means the consumers who are already UC enabled, there are a lot of variations available there. There are various cluster types, access modes available. So I will cover, there are 2 slides for that. This is the first slide. So if you see in a UC enabled workspace, if the cluster type is HMS and the access mode is no isolation, they can still query HMS Metastore, but cannot query an UC Metastore. HMS plus UC cluster type, no isolation shared, they cannot query UC. Shared mode and single user are just the opposite to each other. On shared mode, you can query UC, but in single user, you can query HMS. So it's just the opposite to each other. This is the last variation of UC. So there are 3 cluster types here. Actually 2. The middle one I will describe a little bit more. The UC and SQL warehouse. So if the cluster type is UC, the access mode is shared, they cannot query HMS, they can query UC. Single user, they cannot query any one of them. Now the SQL warehouse, it is obvious, like they cannot query HMS, but they can query UC. HMS plus SQL warehouse is a combination of UC enabled workspace. You can have an HMS cluster if you want to query both HMS and UC together for whatever reason. Then you can spin up an HMS cluster and then use a SQL warehouse to query both the meta stores. So all these different variations we have tested, it is working based on the need of the consumers. They can pick and choose whatever options they want to choose for. The next couple of slides, I will walk you through all the customization that we did during our UC migration. Now, granular level access control. So there were two ways we could have achieved granular level access control. One is create a function, attach that function with a column, and then that way you can achieve a granular level access control at the table level. But we have a policy in PepsiCo where we are not allowing any user to directly query a table. So our only option was giving access through views. So we have a process, automated process available in the system through which we can create a dynamic view, and through that dynamic view user can get access. So next 3-4 slides I will walk you through the process that we have followed. These are some of the tables. There are more tables, that these are some of the important tables we have for this granular level access control. So the first table is the identity table. So when I say identity, there are many different identities in our world, right? We have user can directly query, we can have service principal, we can have managed service identity, we can have AD group, we can have a Databricks account level group. Through any one of these means, user can request access for a given table. So this UC identity table captures all the details of that particular identity. UC table security tells us which tables has what kind of classification. So we in PepsiCo we have 4 different kind of table classification: public, internal, confidential, and restricted. So UC table security captures what tables belongs to what category. UC identity security, this table captures who has requested to which table for what kind of access, whether public access or restricted access. Row security actually captures all the row level access that a user has requested. There are screens, I will walk you through those things. The table column mapping gives us, as we capture all the metadata from source and to the target, table column mapping takes all the metadata for all the tables that we have into the system and all their columns and their column data types. And the restricted, the last one captures all the restricted tables and their restricted columns. And these are some high level ER diagram between these tables. Now, how user request access to a table. So we touched upon very quickly the onboarding portal, right? So this is one of the feature of the onboarding portal. User can log into the onboarding portal and they can request access for a table. So we have we chose 3 personas just to show you how they request access and what data they see and how the metadata looks like. So if you see, this is persona 1. He is requesting access for the table. The table name is there on the left hand side at the bottom. These are restricted table, but this persona and this restricted table, they are a restricted column and they are a non-restricted column in the same table. So this persona is requesting access for the non-restricted column. Need restricted access is no, so he is requesting access for non-restricted column, but he wants to see all the rows of this table. The second persona is requesting access for the same table, but this time he is requesting access for the restricted columns, but he only wants to see the data belongs to the latter market. He do not want to see all the data. This is my third persona. This is the super user. So this user requested access for the same table, restricted column plus all rows. So no restriction for this user. So user requests this request into the onboarding portal. It goes to the respective table owner. Once the table owner approves the request, this is how the data looks like. So on the very first one, from the top, it is telling that particular table is a restricted table. The second one is telling that particular restricted table, which column is restricted. Rest of the columns are not restricted. So it is one column on this table is restricted. The third screenshot is showing you all those 3 personas, whoever has requested access, what kind of access they have requested. The first one has requested restricted access, second one is public access, and third one is requested access. And the fourth screenshot is telling you what kind of row they want to see. The first two person want to see all the rows, but the third person has only requested for the rows belongs to the latter market. Now this is the metadata, and based on all this metadata, we create the dynamic views. So this is an automated process as well, no interaction, manual interaction required whatsoever. So when user queries these dynamics views, that is what they see. So the first persona requested access for all the market, but only for the public column. So if you see, the restricted column become redirected, but market he is seeing everything. The second persona requested access for the same table, but he wants to see the restricted columns, but only for latent market. And the third persona is a super user. He has requested everything. So he's saying all the rows, all the columns, no restriction. So this is how the granular level access control happens. Now the next couple of customization that we did, and I greatly thank the Databricks engineering team, Databricks account team during this journey with Unity Catalog. They worked very closely with us. All the customization that we need, because some of the things were not available in Databricks platform by default. So the Databricks engineering team, the PepsiCo engineering team, they worked together very closely to build some of these customizations. Auditability, we had in PepsiCo, we had some specific data access policy that user has to follow. The purpose of this auditability policy is to make sure that whoever is not following those data governing policies, their queries to be flagged. So we are using system access audit tables, information schema tables, all these tables we are using to capture all the metadata related to a user query. And based on that, we generate alerts. And just to give you one kind of an alert that we generate is when users are trying to clone the entire silver layer to gold layer. That means they are taking the entire data, which they should not in most of the scenarios, because gold is mainly for aggregation purpose or KPI purposes. So they should not be taking the entire data set from silver to gold. So if they wrote a query, just select star from table. There is no where clause, no group by, no nothing. Their queries are flagged. Once these queries are flagged, we generate an alert to the data owner or the respective project owner so that they can take necessary action. So this is one custom solution we build with Databricks. This is another one, cost to sell. So everyone talks about cost to query. So cost to query, what we found during our work with Databricks engineering team, if a query is coming from a SQL warehouse, finding cost is very easy because it already gives me the DBU and I can find out a cost of associated to that DBU. But as I said, majority of our pipelines are coming through HMS. So they are not using SQL warehouse. Hundreds of thousands of jobs are running per day. Finding cost of those jobs are a little tricky, and that's not straightforward. So what we did instead, this gives you cost to sell. So in a notebook, if I have 10 cells, I can derive cost for each of these cells. This cost will not give you a 100% accurate cost, but this will give you a very, very near approximate cost that you can then look back and fine tune. So what we do is we call tons of Azure cost APIs. We store the data into a Delta table. At the same time, we also query system access audit tables to find out all the Databricks events that has been happened, and a notebook, which notebook is fired, which kind of query, which ADF has fired, which kind of job. So all those metadata is getting are mashed together, and based on that we figure out for each of the cell. This is a kind of a formula that we apply, event execution type by job execution time multiplied by job execution cost. So that gives us very good understanding of the cost of each of the cell that a particular notebook has. It also gives us an opportunity to fine tune the notebook, because in a notebook, if I have 10 cells, if one of the cell cost is very high in proportion to the other cells, then it gives us an opportunity to find out how to fine tune that particular cell. So that's another customization we did with Databricks. Then backup and restore. So when we started our journey, there was no solid backup and restore policy of UC Meta Store. So we worked very closely with, again, the Databricks team we created a very, very robust backup and restore mechanism. These are custom code as well. So this backup process runs every 2 hours, and it backs up everything. Like it backs up the meta store, it backs up schemas, table, permission, owner, external location, storage credential, anything and everything is under UC secureable. It backs up everything. And during the backup process, we do checkpointing. So if the backup fails, when we restart the backup, it starts from the checkpointing location. Similar for the backup restore as well. Restore is also very customizable. You can restore the entire meta catalog. You can restore schema, table, any one of them, only one of them. You can only, if you want to only restore the permission for a given table, you can do that as well. The restore also has many checkpoints. So if the restore process fails, you can start from the checkpointing location. So that is also a very, very custom solution that we have built with the database engineering team. These are some of our lessons learned. Like, as I said, we are maintaining UC and HMS Metastore both. So there are scenarios when if there is a schema evaluation happens at the HMS Metastore side, the UC Metastore gets unsynced. So there is a MSCK command that you need to run, Metastore consistency check. That commands you need to run to make sure your Hive Meta Store and your UC Meta Store are in sync. So we have derived our engineering pipeline takes care of this if it detects there is a schema evaluation happened on the HMS side. Dynamic views, when we started our journey 6-7 months back, dynamic views was not being able to share through Delta Share, but it has become GA right now. So it's 6 months back, it was not available. User access control, there are multiple different quotas we have in Databricks. So on a account level, you cannot have more than 5,000 account level groups. So we have to make sure that using dynamic views and some other techniques, we have to make sure that we never reach that quota. External location, there is a limit of 500 external location that you can create on a Metastore level. So as you know, we have multiple data lakes, 16 data lakes, we have multiple different containers, folder structures. So there was a very high chance to overshoot that 500 limit. So we have to redesign our external location policies and procedures so that we never cross that 500 limit. Serverless DB-SQL, we are not being able to query the HMS tables. That's another learning we had. Cluster diversity, I already showed you on the previous slides. There are many different cluster diversities, access mode and all those things. Another interesting finding was RDD APIs do not work under UC. When you go to UC, if you have RDD APIs, there are circumstances where the RDD API call will fail because of some security reason. Databricks is fixing it right now as far as I know, but still, I believe still sitting to the RDD APIs do not work. So you have to convert any RDD API call to data frame API. And through dynamic views or through views, we cannot do time travel. So currently we are working with the product engineering team to find out if there is a solution to that. And runtime upgradation, we have to upgrade to 13.3 if you want to use UC. If you want to do read stream, then you have to use 14.1 and later. The next slide, I will ask Bhaskar to complete. The next couple of slides.
So what did we gain from all of this that Sutitra just walked through? So you probably all have learned a lot today as well that Matthias was sharing. So with UC today, we are getting a very strong access control mechanism because of the requirement that we were put together by the business. Granular access control, we are able to manage access to the storage account level, different that talked about. Insights into the queries, which was very critical because it was one of the objectives set by us that, hey, let's make sure that data doesn't get copied, which is very easy when people start copying data. So we are able to alert those alerts on those situations, and who is even querying the data when we access, and how can we remove the access, giving visibility to the business owners as well, who are the data owners, giving them that report. Monitoring and observability is again built in within the framework itself to make sure that end-to-end lineage is, and we are working on integrating with the UC's lineage. So it gives us that blends all of these together and probably will give a better lineage visibility to the data governance team. And cost is another factor. We are able to protect produce the cost and show it to every consumer of the data that what it is costing when you're building something and the optimization that you can do. So these are the lessons learned. I think hopefully it helps you understand where we are in our journey. A lot of new features that has come up in the UC today. We will be working through those things. Thank you, everyone. If you have any questions, I can answer it.